Hello everyone, it is Friday evening for me. I hope you've had a wonderful week or day or whatever. Today we're going to be looking at how programming will look in the future. So this is an article written by Emil, so don't blame me for the clickbait title. But this isn't about how there's going to be no programming or it's going to be AI, although it probably will be. This is going to be about a language, and this language is called Nevalang, and it's built upon Golang, as you can see. And yeah, we're just going to read what they have to say about this and go from there. So, programming hasn't fundamentally changed since the 40s. Most languages still follow the von Neumann paradigm. By the way, von Neumann was a true G. If you don't know who this is, I honestly think he was like the smartest person that's ever lived. I love me some von Neumann. We're getting distracted already. It's kind of crazy. But look, list of things named after John von Neumann. Yeah, he did a lot of things. But anyway, going back to this, I can't get there. So most languages still follow this paradigm, write sequential instructions, and modify data and memory. Let's look at a simple example. So here's just some Python code, which just we all know just adds numbers from 1 to 5 and outputs the sum by modifying this total variable. So simple and familiar, right? But there's a problem. Modern computers aren't getting faster like they used to. Instead, they're getting more cores. And our traditional programming models aren't great at handling multiple cores efficiently. So that's what this is about. So we've tried to adapt with concurrent tools like Golang. Now, Golang is really good at concurrency. And as I've just said, this is actually built with Golang. So theoretically, anything we can do with Nevalang, we can do in Golang. But this is more about how we represent the code. And it's sort of more simplified, but you can still interact with Golang, or at least I think there's plans to allow you to interact with Golang at a later point, but that's beside the point for now. So these solutions help us, and then here's like a Golang multi-threaded concurrent way of doing this, I guess. Although I'm not great at Golang, I don't really know it that well. So these solutions help, but they introduce problems like race conditions and deadlocks and complex state management. Now, I've not done much Golang, but I've done quite a bit of C. As I said, I did electrical and electronic engineering at university, and a lot of that was C on embedded devices, and we had to work on threads and stuff like that, and mutex locks and all that good stuff. And we all know that's horrible to debug. So we're building on top of that paradigm that wasn't designed for parallel execution. And by the way, actually, that does remind me, at uni we used to use something called, not a lot, but we used something called LabVIEW. God, that is that is a monstrosity. Look at that, who did that? We can find something more simple. I think this was expensive software, by the way, like really expensive. Or at least the device on which we ran it. So yeah, you can do simple stuff like that. It's essentially nodes. There's also is it Red Node JS, I think, as well. I don't know if you've ever seen that, which uses nodes. I think it's a similar sort of concept. This is like a JavaScript thing for, I think, embedded stuff, essentially. Is there a cookbook? Let's have a look at the cookbook. Getting distracted. We'll get back to the article, but essentially stuff like that. I think you kind of get the gist. Now, the difference is this is actually a written language for now, although I think they are working on also giving it that visual aspect, because there's no reason for it to not be able to be visual. So a different approach, data flow programming. So what if we want to write programs differently? Imagine describing your program as a network of independent nodes that pass data to each other. So there's no shared state, you know? It's not like total or, yeah, like anything that you're sharing states for. It's just these nodes, and they get sent. You go from one to the next to the next to the next, which allows you to just do true parallel by default. It does mean, of course, that you lose some sort of, what's the word? I guess lower level control, because you're just using the most simple functionality of the concurrency, because that's all you care about in this particular case, I think. So the data is mutable, so there's going to be no race conditions. So everything's going to be parallel and safe by default, essentially. Yeah, so the program structure mirrors the data flow and natural scaling across multiple cores. So Nevalang does exactly that. And keep in mind, by the way, the writer of this article is also the main contributor, I noticed. But, you know, that's fine. I thought I'd just share this with people because it looked pretty cool. Where were we? So it's a modern language built around data flow that treats programs as message passing graphs rather than sequence of instructions. So you can see here we've got a stream of numbers which gets passed to this node, I guess, so it has two nodes, which is a for with a print inside it, a wait, and then I'm guessing and then the stop signal is sent. So I missed the first line as well. So the main receives a start signal and sends a stop signal. So start signal, stop signal gets sent. So we send a start signal. We send the stream of numbers in parallel to this for print. And you know, there's a number of, obviously depending on how this for print is implemented, there's a number of ways that could look. And then a wait signal, and then wait, sorry, for it to complete, and then a stop signal. So again, I mean, it looks like this. So you can see the code is like a visual representation of this. Now, it might be still hard for you to visualize this properly, but you can sort of just imagine like a network of, like a physical network of nodes. Like, I don't know, let's have a IoT network, see what comes up on images. I mean, it's not great. Something like, yeah, I guess something like this, going from here to here to here, so like a cloud thing, or various devices. So somewhere where you have a flow of data and you're doing various bits of processing, this really does make sense to use, and it might actually be really neat and easy to look at, rather than having a bunch of different functions that you essentially have to manage the states yourself. Obviously, if you prefer doing that, that's still going on under the hood, of course. So Nevalang represents a fundamental shift in programming. I mean, I wouldn't go that. I get what they're saying. It's cool, but I wouldn't go. I mean, it's obviously I wouldn't go as far as saying it's the future of programming. Because the future of programming is probably not doing any programming, but the tools still have to exist. You know, AI can't just like make code without these tools. Anyway, embracing a paradigm naturally suited for parallelism, parallelism. I'll go with that. And visualization rather than fighting traditional programming limitations. Anyway, let's see what the comments say. Cool piece, quite a unique and interesting article, cool language. It is cool, that is good to know. It sounds like more functional programming, especially with something like Erlang Elixir. Yeah. Exciting times ahead for programming. As technology evolves, I believe we'll see even more emphasis on automation and AI-driven coding tools. Well, yeah. Yeah, I think this is still pretty neat. I thought I'd share it with people. And yeah, let me know your thoughts. I should give it a try, really. I always say I'm going to do that, and then it's just life. Let's see, what have we got? Let's have a look at the add numbers. That's the one we saw, I guess, already on the article. So start, and then 1 + 2, print line, stop. Compare values. I feel like it would take some getting used to, but you can once you understand that you're just sending like from one to the next by each arrow. So you have a start signal, and then you're doing this thing, and then you send that to the print line node. So this is like a logic node, I guess. Then you're sending that to print line and then stop, and all of this can so you can have a bunch of streams doing this. So this is where it gets more interesting. So you can see we've got a bunch of different things we're doing, and you just send it from one to the next, to the next, to the next, to the next. And then you can have like a function where's even, filter even, it's probably defined as somewhere. But yeah, that's pretty much it, I guess. So yeah, hopefully you like that. leave a like and all that stuff, and let me know your thoughts below. Have you used it? What are your thoughts?